Hi everyone, welcome back to the Code to Conquer series, your step-by-step guide to mastering DSA for placements. This campaign is brought to you by the Google Developer Group site VIT-AP. You know that we've already completed half of our journey, covering arrays and greedy algorithms. Great job sticking with it so far. Now let's move to the second half of this by moving to linked lists. So I'm assuming you guys have an idea of a linked list and do not need any deep basics to be covered here. So I'll just be moving on without covering any basics. So let's directly go to the question. So what are we asked? So we have to create a program uh, which will be having the methods to insert or delete from the nth position, both from the nth position. Coming to the description, it just explains the problem statement. We just have to have two methods or functions so that we can insert or delete when we are given with the key and the position as the input. So yeah, that's it about the description. There's nothing more in there. So coming to the test cases. 0 stands for insertion, 1 stands for deletion, position, and then key. Let me explain. So looking at the input, we have 0, 1, and 10. What does this mean? 0 stands for insertion, as I said. So we have to insert 10 at the first position. Similarly, we have to insert 20 at the second position, 30 at the third, and 40 at the fourth. So if we traverse through our linked list, our output would be like 10, 20, 30, 4. Going to the next input, we have to insert 10 at the first position, 20 at the second position, and we have to delete the second node, which means we should be deleting the 20. So we'll be left with 10. Oh, sorry, we'll be left with 10. So going to the next one, we have to insert 10 at the first position and delete the first node, which means we should be deleting the node which we just inserted. So we will be having nothing in our linked list and the output would be null. Going to the next one, we should be inserting 10 at the first position, 20 at the second position, 30 at the third, and we should be deleting the first node. 1 stands for deletion and we have to delete the first node. So we'll be removing 10 from our linked list. So we'll be left with 20 and 30, 20 comma 30. And then we have to insert 40 in the first place. So we'll be having 40, 20 and 30. Then we have to insert 10 at the fourth position. So our linked list would be finally 40, 20, 30, 10 as in the output. So now let me give you a brief introduction of what a linked list is. I know most of you guys know, but let me just revise the basics. So linked list is nothing but a data structure which will be having two parts in it. The first one will be the data part, and the next one will be the address of node itself, but the node next to it. It will have the address to the next node. So let me draw a basic small linked list 2, 3, and 4. Every node in the linked list points to something else. So 4 should also point to something else even if it's the last node, right? So it will be pointing to null. So 1 points to 2, 2 to 3, 3 to 4, and 4 points to null. This is a basic linked list, very basic linked list. So the first node will always be called the head. We should not tamper the head. We should always have the information about head and it should not be tampered. If we tamper the head, then there is chance of losing a linked list or it will be distorted and it will cause problems. So make sure that you do not involve head in any of the operations we perform. So yeah, I think this is enough. Let's go to the explanation. I mean the code. Yeah. So we have a code here. So you guys know uh, we should always have a node class in the questions or the implementation of linked list. So what does this node class have? It has an integer key and a node next. So we'll also have a constructor with the input as the key. So this key will become this key and the next will be pointing to null. So this is the basics of linked list and I'm assuming you guys know. So next we'll be having our head, node head, which we should not be tampering. So, and the constructor of the main class will make sure that our head will be null whenever we restart the program. That means whenever we click run, the head will be set to null so that we do not have any problems with the previous linked list. So we'll be creating new linked list and head will be pointing to null. Now let's come to this insertion. We'll be given with our key. We should be inserting at the required position. So let me explain it. So now let's look at the insert method. So the first step in insert method is always creating a new node with the given key. So assume we are given with an linked list like this, and we want to insert one in the first position. So the first step would always be creating a new node with the given value, and we want our linked list to look like this. I mean, the 1 would be pointing to 2, 2 would be to 3, and 3 to 4, and 4 would be pointing to null. This is what we want, is our final linked list. So we have to do something so that we want our 1 should be pointing to 2. So look at this. Uh, yeah. So we always have this two conditions. I mean, we can insert a new node at the first place in the linked list or else anywhere in the first place or any other place. So if we have the position of one, I mean we want to insert it as the first element, first node. We want to insert the new node as the first node. We just can we have a node as we created previously. We just have to point its next to the head. So uh, if we point once next to the head, then we can say that one is our new head. I mean, one will become the first element of the linked list, but still two is the head. So we just have to make sure that we name this as head. So we just have to do this step. Head is equal to new node. So head will become one, and two is not the head anymore. So one is the head, and this is our final linked list. One, two, three, and four. So this takes care of this condition if position equals 1. What if the position is not equal 1? And we want a new node in the middle of the linked list or at the tail, I mean, as the last element of the linked list. So we have to perform this part. So what does this mean? Uh, First thing, we point a pointer called current at the head. So let's, this is the previous case, right? So yeah, assume we want to insert a new node with value 7 at the position 3, which means we want our new node to be over here with 3 pointing to it and it pointing to 4, and there should be no link between 3 and 4. We want it like this, right? Right? So what should we do? We initially have a linked list like this. We want our 7 to be between 3 and 4. I mean in the third position. In the third position. So what can we do? As I said, this is the head. We will be pointing a pointer called current to the head. So the current will be at 2, and we will make sure that current reaches the node after which we want to place our new node. So we should make sure that current reaches here, not only over here. Assume there are maybe like 100 nodes in a linked list, 100, and you want to insert a new node in the 30th place. So you should make sure that your current reaches the 29th place so that you can insert a new node after this, and you can make this the node inserted. I mean, if you want to insert at the 30th place, make sure that your current will be at the 29th place. So similarly, we want to insert at the third place. 7, we want to insert 7 at the third place. So make sure that your current reaches this. How can you do this? You can do this using a for loop. This for loop. So you have to start with I equals 1 and you have to move till I is less than position minus 1. I plus plus as usually. And you have to move till I is less than position minus 1. So the position over here is 3 and I is 1. So I is less than, for I equals 1, we have to run this once. So what does this run? Current equals current of next. Current of next. So current just moves to the next node. So current moves from here to here. Current moves to current's next. So current is not over here anymore. Current is over here. Now I is incremented by 1. So I becomes 2. So I equals 2 now. Now I equals 2 and position minus 1 also equals 2. We cannot say that I is less than position minus 1 because 2 is not less than 2, right? So this for loop stops and our current is over 3 right now. So what should we do after this? So we made sure that our current pointer reaches the node after which we want to insert. So and we also have created this new node. So what can we do now? Let me draw it a little bigger. 3, 4, and we have our new node to be inserted between 3 and 4. So what can we do? This is the current. This is the new node. Yeah. So what can we do? Uh, we should make sure that the new nodes next should be pointing to the currents next. So 7's next will be pointing to currents next. And currents next should be pointing to the new node. So this will be gone. So this is exactly what we need, right? So currents next will be pointing to the new node and new nodes next will be pointing to currents next. This is exactly what is written in the code above. Let me show you. See, this is exactly what is written in the code. New nodes next should be pointing to currents next. Currents next should be pointing to new node. I hope you got it. Now you might ask me, what is the point of this if condition and why are we using this in the for loop? Now let us assume, so I hope you got inserting 7 at the third position. Now let me give you another example. Suppose you are having a linked list like this. 1, 2, and 3. 3 points to null. So it's a linked list of length 3. Now, if you are asked to insert 4 at the 10th position, can you insert it at the 10th position? No, you can only insert values, nodes up to the 4th position, right? You cannot insert it at the 10th position because there should be something in between as well. So, uh, what does this do? Our position now is 10 and I is initially 1. Position minus 1 would be 9. So I keeps on moving. I keeps on moving till it's 9. So I keeps on moving till it's less than 9. But our current reaches null before I reaches 9 itself. So what should we do? If our current reaches null, we cannot move any further, right? Even if I is less than position minus 1, if our current reaches null, we cannot do this step because current equals current dot next. So if current equals null, there is no such thing as null of next. So we should immediately stop if our current reaches null. So what do we write? If our current only run if our current does not equal null. If our current equals null, then immediately stop this. This step should not be executed anymore. And after this, if our current is null, which means that we reached null and we have to insert it after the null. Just display that we cannot insert it because it's invalid I mean, you cannot insert uh, a new node at the 10th place in the linked list of length 3, right? So just display that it's invalid and return. Do not execute these steps. But if we are in somewhere, if we are in between the linked list, I mean, if we can insert the new node after the current node, just execute these two steps, and yes, finally our new node will be inserted like this. Let me write. So if we insert 7 in the third position, this will be a new linked list. So if we can insert it like this, if we cannot, just display that it's not possible, and end the code. So let me summarize this insertion part. So let me just summarize it. First things first, create a new node with new value. Next, if the position to be inserted, if the position to be inserted equals 1, just make sure that the next of new node will be pointing to the head, and the head will be renamed with new value. So that the new node will be pointing to head, and this will become the head. So this is not the head anymore. There is a linked list existing over here. So that's the case if the position equals 1. I mean, we want to insert it at the first position. Else, if we want to insert it in between the linked list, or at the last node. So we have to make sure that current reaches the node after which we insert want to insert the new node. If the current reaches null, it means that we cannot insert a new node, and just display that we cannot. But if the current is not null, is not does not equals null. If current is not null, then we can uh, insert the new node in place of current, and it's next. So I hope I summarized it properly, and let's move to the deletion part of it. Coming to the deletion part. So when coming to the deletion part, if there is no linked list, I mean, if the head is null, will be given with a position. We have to delete the node at that particular position. If the head equals null, what does this mean? What does that mean? There is no linked list existing. We cannot delete a node from unexisting linked list, right? So if the head is null, just print that list is empty and return. So we'll just return, and the code stops over here. This part is not executed. If the position equals 1, which means that we want to delete the head. If we want to delete the head, just make sure that the head points to its next, which is exactly what is written over here. Just make the head point to its next. Move the head. Let me draw it. Suppose we are having a linked list 1, 2, 3, and we want to delete this one. So, and this is the head as well. We want to delete this one. So what can we do? We can make this head point to 2. So this head will be the 2 now, and we do not care about this. Even if it points to 2, we do not care. In the coming operations, this will be our head. As this is a single linked list, we cannot move backwards. We only have to move forward. So we do not care about this. Let it point to 2. It's none of our business. So the head will be pointing to 2, and all the operations will be done considering 2 as the first node. So this is what is exactly written over here. Head should be pointing to its next node, and just return, so that these things will not be executed. Coming to this for loop, similar to the one in insertion, you just have to point current pointer to the head and move it till the node after which we want to delete. I mean, if we want to delete the third node, move the current till the second node, right? If you want to delete three three from this, make sure that your current reaches till here. make sure that your current reaches the second node. So if you want to delete the third node, make sure your current reaches the second node. This is similar to the one in insertion. So after reaching the required node, if the current equals null or the next of current equals null, if the current equals null, I mean if the current reaches over here or to the tail or the last element, the next of current equals null. I mean if the current reaches the last node, what does this mean? Current reaches the last node. Just print that it's invalid, right? The next, if it's possible, I mean if you want to delete the third node, what should you be doing? You just have to make sure that this is gone. Let me. This is gone, and 2 should be pointing to null. You just have to make sure that this happens, right? So just make sure that currents next should be pointing to currents next of next. Suppose you want to be deleting 2. Let's not consider 3 to be deleted over here. Let's consider 2 to be deleted. So current will be over here. So once next should be pointing to 2's next. So that we can, while traversing, we go from 1 to 3 directly instead of going to 2. So we are eliminating the path of 2 in between. So if we want to delete the 2, the current will be pointing towards 1 and 2 will be deleted. How can we do that? Using this step. Currents next will be pointing to currents next of next. I hope you are getting this. So if you want to delete 2, just make sure that you are at 1 and points 1's next to 2's next. I mean, what is currents next of next? If you want to delete 2, this is to be deleted. And your current is currently over here. And you want to delete it. What is currents next? Where it should be pointing this thing. Where should one be pointing? What is currents next of next? It is nothing but 3, right? So currents next should be 3. I mean 1 should be pointing to 3, forgetting 2 in between. So that we do not have 2 in our linked list and we can directly point like this. So this will be gone. We do not care if 2 points to 3 or no. It's none of our business. We just have to make sure that 1 points to 3. So while we are traversing, we have 1 and 3, but not 2 in between. So let me summarize this as well. First thing, if the head equals null, list is empty. We cannot delete any element. If the position equals 1, which means that if we want to delete the first element, just point head as its next element and stop the execution. Stop the execution. You will just return. Else, you want to delete some element in between the linked list, point your current to head and move it till the node uh, af- after which you want to delete. I mean, if you want to delete the third node, make sure your current reaches the second node. Then, if the current is null or its next is null, I mean, if the current is null or you are over here at the third place, just print that this is an invalid position. This is because you do not want to delete 3. If your current is at 3, you do not want to delete 3, but you want to delete the element next to 3. So you cannot eliminate null, right? So if the current equals null or currents next equals null, I mean you are at the tail, you are at the last position. You cannot eliminate the node after it. There is no node after it. So you cannot delete the node after it. So you should just display it's invalid and return. You should not execute this. So if you are somewhere in between and it's possible to delete, just apply this step. Currents next will be equal to currents next of next. So this completes deletion as well, and I hope you understood the deletion well. Now let's come to the code. So we have completed deletion. Now let's come to the display. This is nothing. The head is null. Just display that there is no element in the linked list. Just display null or display the list is empty. Or if it's not null, then you can, it means that you have some elements in the linked list and you can display them. Make sure you point your current to the head. I mean, current is just a pointer pointed towards head, and move the current of currents next. Move current to its next till it reaches null, displaying its key. So if you have a linked list like 1, comma 2, comma 3, comma 4, current will be pointing to 1. Current equals head, right? Current will be pointing to 1. So after this, display currents key. I mean, one will be printed, and current will be going to 2. So current is at 2 right now. Display 2. Current will be going to 3. Display 3. Current will be going to 4. Display 4, and you will reach the null. You will reach null over here. So this while loop will be terminated, and you will go to the next line. So this is completely display. You can display using this format. Now this is basically the question. I mean, basic Java. So uh, if the input will take input uh, for the insertion or deletion or to exit the program. If we want to insert, we just give an input as 0, for deletion 1, and 2 to exit. So if the operation is 0, we take the key and the position and give it to the insert method. Similarly, if it's deletion, we take the position and give it to the deletion method, and after everything, we display it. So this is completely about single linked list. So I hope you got the insert. This is important. Insert and deletion. The rest all can be covered in Java. I mean, it's basic, and I hope you can get it. This thing and this thing. These are important. So if you got these things, then I guess you're good to go with linked list. Yes, single linked list. Well, this brings us to the end of the first problem today, day 16. And I hope you are clear with single linked list, at least the insertion and deletion part at the nth position. We'll meet you with the next question. Thank you.